Okay, we're going to take a look at Chapter 4, Section 15, Linear Trends in Data. So we've been doing a lot of stuff with inequalities lately, and starting with, this is the last section of Chapter 4, and we're going to take a step back from inequalities and look at a few other things. So, linear trends in data, our goal is to be able to identify trends in sets of data. We'll spend a lot of time in class talking about that. And what we're going to really focus on in this video is the second goal of finding the balance point of a data set and estimating the line of best fit. So to be successful with this, there's a few things you need to be able to do. And the first one is that you can construct a scatter plot. Second thing, be able to calculate the balance point and calculate the slope, so two calculations. And then the last thing, if you can write the equation of a line in point-slope form. So all of those things should sound super familiar as things we've done in the past in this class and then also in middle school when you're first introduced to all of that. So really what I need to show you is how does all this stuff come together to help us as we analyze data. So let's take a look here. I've got a table of values, just some random data points here that I put together. So I want to make a scatter plot, and I'm going to review this with you real quick on how to do that. So first of all, I'm going to draw my horizontal and vertical axis. In this case, yes, they are the x and the y, but with a scatter plot, oftentimes the data is contextual, meaning there's a certain scenario we're looking at. If you remember, when we first learned scatter plots in this year, in Algebra 1 back in September, we worked with height and shoe size was the focus, where we plotted shoe size and then person's height, and then we use that to predict, future heights based on what your shoe size was. So on my x-axis, if I'm just going to sketch this real quick, and I'm not going to finish it by hand, just want to remind you how this works. Go to x6, y5, put a point. That's my first one. My second one, x10, be 10, 8, be about right here, etc. That's my second one. So continue that until you have all, and I have 10 coordinate pairs there plotted. And this is what it would look like here on the screen now. So I plotted that, I made a scatter plot. Okay, so the next step, the next thing we need to do is calculate the balance point. So this is one of our success criteria, and this is new. So the balance point is the, I like to write it like this, the average of x, comma, average of y. So average those two together. Okay, so as I add up x and divide by 10, okay, my x value ends up being 15 and a half. And then I'm going to add up the y's and divide by 10, which ends up being 12 and 6/10, or as we like to say, 12.6. And that's my balance point. Okay, so this is super important. This is like where all the data balances together. So we're saying on the x-axis at 15 and a half, if I come over here, all of the data values I have kind of average out to being right here on the x-axis. The y values average out to about 12.6 on the y. Okay, so if I look vertically, it looks to be about the halfway in terms of average, not median, but halfway in terms of average, and on the y-axis as well. So I'm actually, these lines here are just here to represent that, but I'm going to actually plot that point right about there. So okay, so I calculated the balance point and I plotted it on my graph. The next thing I want to do is sketch in what we call a line of best fit, or in this case might want to say a line of good fit, since it's not going to be exact, but it's going to be pretty close. Okay, so if I start it with a line, and for you, you're going to use a straight edge, maybe your ID, depending on how big your graph is. And you're just going to move your line around, it has to go through the balance point. That's super important. So that red dot on the screen there has to go through that. And then I want it to be really close to all of the other data points. Now obviously it can't go through all the other data points, but a line like this, most of the data points are below it. A line like this, most are above it. Okay, so I want to get it to the point where I feel like it's real close to all the data points. Now, again, this isn't exact. This is, in my opinion, just sketching it in, and I don't know, I might even change it. I could play around with that for a while, but for the sake of the example, we're going to stick with that. Okay, so I calculated the balance point, I plotted my balance point on my graph, I sketched in a line. All right, now the next thing I need to do is calculate the slope of my line. Okay, so to do that, I'm going to use the balance point as one of the points. And then I need to look at the line and find another point that's somewhere on the line. And, oh, this point right here looks pretty close. This one's close but not exact. And I also noticed that, oh, it looks like the line goes through this spot on the coordinate grid. So I'll use that point, and that appears to be 7x7, y5. Okay, so I'm going to calculate the slope using 7, 5, and 15.5, 12.6, or 12 and 6/10. So change in y, 12.6, 5 minus 12.6. Change in x, 7 minus 15.5. Okay, now this is going to be really, really ugly. It's not going to be a pretty fraction. It's not something that we're going to simplify. So I do that with my calculator here. But this is my slope. And usually we're used to it being a nice fraction like 1/2 or 2/3 or maybe even a whole number. Well, in this case, when we're working with some real life data and we have a specific scenario, very rarely does the slope come out to being what we might call a friendly or a clean looking number. Okay? Alright, so calculated the balance point, plotted it on here, sketched a line in there. Okay, nothing new there. Now I calculated the slope. The last thing I want to do, because my goal is to estimate the line of best fit, last thing I want to do is write the line of best fit. Okay, so we're going to do that in point slope form. So if you remember what that looks like, y minus y1 equals m times x minus x1. And what we're going to do is we're going to plug in our slope and we're going to plug in our balance point, and we're done. So y minus the y coordinate, my balance point, equals my ugly looking slope there, 7.6 all over 8.5 times x minus my x coordinate in my balance point. Okay, I have just written the line of best fit for this set of data, or a line of good fit. It's pretty close to there. I've written the equation of that line in point slope form. At this point, there's a few other things we're going to look at in class in terms of determining whether or not it has a linear trend, so it follows in a line, maybe make some predictions based on our line, some things like that. But the math that's involved, the actual calculations and the writing of the equation, that's it. That's all we need to do.